What was that?
I think that was lecture. Okay, if we all write down what we remember from lecture, we can probably piece it all together.
Yeah.
Mm-hmm. Okay, so let's recap. We're going to have to make a fixture for the IME 144 class next fall.
Yeah. So we'll do 3 parts, 2 ops per part.
So that's 6 ops total, okay, and that will make 1 full assembly piece.
And we'll use the Mighty Bite rails and clamps Treon provides.
Is that a duck? Nice.
Yeah, you're going to be doing the video.
Okay, so I got less than 200 pounds for mine. What about you guys?
Awesome. The Mighty Bites will hold 800 pounds, so we won't need more than 1 per cart.
Cool. So the primary datum is on the top of the fixture, but what about the secondary?
Well, we can use the rails to locate the secondary datum and then clamp off of those. And then for the tertiary datum, we can use a 1/4-inch dowel pin.
Okay, sweet. Now let's all work on our own designs, and we'll come back and vote on the best one.
Through the design process, we focus on making the fixture easy to set up, clean, and install stock. We discussed how to fit all of the parts onto the fixture plate, and finally settled on having all of the first operations evenly spaced. We also added a slot where the holes are to be drilled in order to allow for easy cleanup after running parts.
Nice.
It's a duck. Another duck. We're going with yours.
あの交差点でみんながもしスキップをしてもしあの街の真ん中で手をつないで空を
Yep, I just ran the cam for the fixture and the 144 pieces at the same time. Now I'll just post the G code, and voila! We have a fixture that can machine all operations at once. Do you think we should have Dustin or Jake look at the G code? Nah, you're right. Let's go find Treon. Oh, hey Treon, can you take a look at our code? Thanks.
The location of each part on the fixture allowed easy establishment for work offsets. The only issue that resulted when CNCing our parts was that 2 of the screws for the clamps were cut during the edge milling process. These nicks only resulted in a small removal of material, about 5 thou deep. With a second iteration of the clamp, this problem would be easily solved.
So let's look back. For this project, we were given the criteria for our fixture design, including the cutters used to mill, the fixture parts, and the size of the stock to be milled.
We were also given the necessary CAD files for the 144 parts in order to make sure that the machine didn't run into the fixture.
Next, we calculated our tangential cutting forces, and we chose the fixture components that met the load specifications.
Then we all designed fixtures and voted on the best one. JR made a duck.
Yes, indeed he did, and what a marvelous duck it was. However, in the end, we did end up choosing a combination of our 3 designs, which included etched words and a relief channel for the 144 students to be able to understand how to use the fixture in the best possible way.
We generated G code using HSM words and tested if the machine was going to run into the fixture. Our code was approved by Treon, and we machined and assembled our fixture.
We then ran the 144 parts, and you know what? They came out beautifully. And we have no doubt that these new fixtures are going to be great instructional aid for the new students.
Thanks for following us, and yes,
Well, on that note, goodbye and happy machining.
Watch out!